Hello everyone, Through here. Welcome to today's presentation. So in today's presentation, we're going to do a deep dive into the tMap component within Talend. The tMap component is arguably one of the most versatile components when it comes to processing data within the Talend environment. As the agenda for today, we're going to look at basic mapping within tMaps. How do we do simple basic mappings? We're going to look at arithmetic operations, calling functions or calling Java class methods. We're going to look at calling routines, and then we're going to look at conditionals, if-else statements within the tMap component, a very powerful and a very versatile component to have in the tool belt for data processing. That said, we're going to switch over to the studio environment and begin. Before we start building the jobs, we have two data sets we're going to be using in this scenario. We have our customer data set and we have the order data set, which I've already connected to here. These are basically flat files, and we can do a preview of this data set to see what we have in there. The customer basically holds the information about the customers or the customer records we're going to be working with. So just a few records here, about 10 records. And then for the orders, so these are the orders that have been placed by those customers. And we're going to be using this as part of the tMap to do joins. So at the very high level, we want to take the customer information, bounce it against the order information, do some aggregations to see what our customers are ordering, which we can then push down to a report for business intelligence and such. So we do have our connections established, very basic. If you're not sure of how to establish connections, just check around for a video that shows how to create connections and such. Now we have a blank canvas for the job. The very first thing we want to do is bring in the order information to the canvas. So I can just drag that to the screen, and it's a file delimited input which we need to bring to the screen. But if we go back and look at the data set we're working with, let me actually bring that to the screen. We can see that the orders that we have coming in is kind of like the fact table. All right. It has a lot of transactions, but we need to aggregate that order to the customer number. So the customer might have multiple orders. If I had more columns in here, say to a date, we want to roll up all those orders to a particular customer. As an example, customer number 3 here has an order of this amount, and they also have an order of this amount. So we need to somehow roll it up or do some aggregations, grouping by the customer number, so we know exactly what each customer number is ordering. So that's the very first thing we're going to do before we start doing our joins. All right, that's it. We've brought in the orders information in here. Let's pass that through a t aggregate row so we can do that aggregation. So we can do the aggregation up to the customer number. All right, so we need to aggregate to that customer number before we then do a lookup to the customer dimension. So let's bring this in here. Let me zoom in for a second so we can see exactly what's going on. All right, so now we have our customers going to aggregate. So we want to aggregate the information to that customer number. I'm going to select that component, and in here we can go in and aggregate. So, but before we aggregate, what are we getting as an output from this aggregation? We're gonna get, if we look at the schema here, we have two columns coming in, customer number and amount. But what we want to get out of that, and I'm going to move all the components, all the columns to the right side. We have customer number and amount on this side, but in addition, we want an extra column in here, which would be the total amount. So that's what would be the result of our aggregate, and we can go ahead and delete that amount because we don't need it anymore. Once we do our aggregation, we're leaving the total amount in the output. So the input is the amount, output we want total amount. And of course, that should not be a string. That should definitely be something like a double. All right, we're gonna be careful that data type. I cannot make it integer. Integer will not be a good idea. So either a double or a float. Let's actually just do a float since that was a float originally. All right, so that gives us the output. Now we can do our aggregations here. So the aggregation column or the group by column is we're grouping by customer number. So that's pretty straightforward. If we had multiple columns to group by, we're gonna use that here in our group by. Now in the operation. So what operation are we trying to perform? All right, so basically we want to perform a summation operation. So in the case here, since I have 3 and 3, I want to group this and summarize this amount. So it should be this plus this, right? So should be about what, 77 78 or so, something like that, if my math is correct. Not sure if I got it correctly, but that's what we need to do here. So I'm going to add a new column in my output. So now you notice the output column that I want is total amount. All right, so I'm going to select total amount. That's where I want my output to be. Then as the function, I'm going to use sum. All right, so sum, I'm going to sum something and put it into this total amount. Now, what am I summing? I'm going to sum, I'm not summing customer number. We're not summing customer number. I want to sum the original amount. So we're going to take the amount, which is the input column, do a summation of that, and then put it into the total amount. What if we see null values? We can go ahead and ignore that. Not very necessary here. I know there are not null values in my data, but in case we see null values, we can just go ahead and ignore them. So now I have 2 columns going out. One is the customer number, and then one is total amount. And we can just quickly, I'm a fan of verifying the things that we do. We can go ahead and quickly just verify what we did here to see that the aggregation is coming out correctly. All right, so now we see that this gives us some good aggregation, and this was 3, actually it's 98, and my math was wrong. All right, so it's summarized 3. All right, so it's added 34 plus 60, yep, 98 point something, yeah, 98.45, which makes sense. All right, so it's summarized this and this. So we now have the summarization we now have our summarization by customer ID, and that's what we do. So we know the exact amount each customer ID is ordering. But we want to take it to the next level and actually bring in the tMap. So this presentation is talking about here we're talking about basic tMap mappings. All right, so that's what we're really looking at, basic tMap mappings. So let's bring in a tMap, and the tMap would allow us to join the order information to our customer information. So I'm going to bring the tMap. I'm going to go ahead and bring my customers. All right, okay. Now, once we have a tMap, I want to take these orders and link them to the customers. But we can connect these two to the tMap, but it's important the order to which we do the connections to the tMap. So the very first component we connect to that tMap, the very first one comes in as the main. So this is the main. And if you notice, if I connect any other thing to the tMap, it comes as a lookup. So assuming that I had multiple lookups that I needed to do here, all right, if I connect any other thing to that tMap, is going to be a lookup. So this is very important. If I wanted this to be my main and everything else to be the lookup, then I would have to connect this first to the tMap. All right, so that's just a little pro tip there to be aware of with the tMap. So the tMap always has one main entry and then a couple, and then one or many lookups. You can have as many lookups as you need. All right, so now I have my orders, and I'm going to do a lookup against my customer so I can get the details of that customer from the customer information. So now let's open up the tMap. The way we do that is we can select the component, the tMap, and then map editor. We can click on that. Alternatively, you can double click on the tMap and it brings you up this tMap editor. Now the tMap is one of the few components that gives you this ability to bring up an editor for you to do your edit. All right, so in the case of say t-aggregate row, if you notice, there wasn't any editor. I mean, apart from viewing the schema, there wasn't really an editor per se. So the tMap, among a few other components, does give us this editor that we can use. So I'm going to go ahead, double click on that, and now I have this editor to use, and this is where a bulk of our tMap functionality is going to happen. So this is where a bulk of that processing of that data would happen. So now, what's the first thing that we need to do in the tMap? We notice we have our row 2 and we have our row 3, which is the customers. So what I can do is I want to join this customer information, so customer number, it's a common key to customer number here, so I need to join that. All right, now before I go ahead and join that, one of the things I always try to do, just from a best practice or just from an ease of use perspective, is I'm not happy with why it shows up as row 2 here and why this is showing up as row 3, because really I don't know what row 2 is, right? It's just some arbitrary name that I really don't know what it is. So we can fix that. So I can go back here, this is really a good habit to get into. I can just make sure click on that 2 times really slow, so we can go ahead and rename that this particular input. So in here I'm gonna call this orders. All right, now the next one out here is called customers, so I want to go ahead and rename that to customers. All right, and we'll see why this is important. The reason why this is important is if I come back now to my tMap, you'll notice I have orders and I have customers, and this is really, I would say, it's pleasing to and more readable to the eyes. All right, so I know I want to join my orders to my customers, do a lookup or a join against that. And the way we do that is, since the common key here is customer number, I'm going to select my customer number and hold it all the way to here and just leave that. Okay, and then that brings that information to me. It shows that this column has been joined to this column across the 2 different tables. So that's how we do the joins within the tMap. Alternatively, we can start typing. So we can say orders dot customer number, and it would automatically do that for us. So you can either drag that over, or we can just start typing, and it knows that these two tables are connected, and you can connect any other table you want. So there could be as many joins or many keys linked as we need. All right, so usually tables are not just joined by one keys. You might have a table with compound keys and multiple keys. We can certainly do a linking that way. All right, let me delete that since that's not the correct join. All right, so this is what we have, and there are multiple kind of joins we can do. We can also go in here and do change the kind of join. So left outer join, we can change that to an inner join depending on the data set and the requirements we're working with. So there is a lot of flexibility to change the joins we're doing here. We can also change the lookup model, right? Are we loading row by row? Are we reloading each row? Are we doing some caching? So depending on the data set that we're working with, you can really have fine-grained control over the join criteria. And so this is how we access these configurations. All right, so that's it. We have our joins on the left side. Now we need the output. We need a result on the right side to work with, and that's the next thing that we are going to build. So the way we create that output, is on the right side. We can go ahead and add, and if you notice the green button here, it says add an output table. All right, so this is the output table we're going to be adding. Let's give it a name. So the name should be, let's call that customer orders. All right, so customer orders or orders by customer, something like that. It should be fine. So we have our customer orders, and this is where we can bring records from any one of the inputs that we have. So on the left side we have our input, on the right side we have our output. So I can decide on the left side I want to bring in my customer details. I can bring it one by one and bring those column names over. All right, and this is I usually prefer to do it this way. You can bulk select with the Control Shift and bring all your customer information over. All right, and so this is how we do the mapping. But now I don't need just the customer information. I need the customer information along with the orders. So now I can go back to my orders information and I can go ahead and bring the order table. So you can see orders, the total amount is coming from this side, and customers.customer number is coming from this side. If I brought in customer number, it was just going to be a duplicate because I already have a customer number up here, so I can skip this one row. All right, so it gives us more fine-grained control in terms of what we want on the output side of things. Okay, so this is the basic mapping that we have, and this gives us an idea of how we can take multiple inputs, do our joins, do our lookups create an aggregate or create an output table, which we can then write to a database, we can write to a file, we can write to any persistent storage. Still very basic. There's a lot of details we're going to get into, but at a very high level, this is one of the most basic mappings we can do. All right, there is also the auto map capability in here, which we can use, but I'll talk about that in a little bit. Now that we have that, I'm going to go do OK, and let's just do a T log row so we can see the result of the mapping we just did here. So I'll take from the component. So I want to take my component from here, right click, customer out, that, and now I have my customers going to the log row. So if you go ahead and run this job, we should see some results on the screen. So let's give it a try. All right, so there you have it. So in here we have 14 records coming in from the other information. We're doing the aggregation, so we're aggregating to the customer number. So once we've done the aggregation, we have just 12 records coming out from here. Then we're taking the 12 records, we're doing a join against the customer number, and this is a left outer join. So we have 12 records here, and then we have 10 records. So this is sending out 12 records, of course, because it's a left outer join. And that's the 10 records we're writing to the screen. So a very basic scenario, very straightforward at the very minimum. This is the most basic, I would say, one of the most basic tMap functionalities that we can have. All right, this could be customer number, it could be orders information, it could be, depending on what your data type or the data set you're working with, you can certainly reflect that in your scenarios. Now let's switch gears here for a second and look at the next capabilities of how we can really elevate, or how we can really improve the capabilities within the tMap, doing things like arithmetic operations, and then maybe calling functions as well, both Java functions, your native Java functions, and as well as calling routines within the Talend environment. So that said, we're gonna come back to the job that we have. Make sure we have our tMap open, and we're gonna look at some scenarios for leveraging functions within Talend environment. So Talend does provide a whole library of functions, and one of the things that we can do is to say, all right, let's do some basic arithmetic operation. So instead of just writing out the total amount, let's do the total amount plus maybe some bonus, right? That bonus could be 50. All right, very basic. So we can just do basic operation. So I'm just gonna go in here and start typing. So plus 50, and you'll notice actually 50 is small. Let's do 5,000 so we can really see the difference. And the reason why I do 5,000 is because the numbers here are small, so we can really see that there is something changing. All right, so just think about your basic arithmetic operations. We can start injecting them in here now. So if I go back and I run this job, what we'll notice is my numbers here would be way bigger than it should be. All right, as you see, the numbers here way bigger than it should be. Ideally, you want to leverage context variables for that. We can certainly use that and pass that number instead of hand coding 50 into the code, but this is just from a demonstration perspective. So we can see here 5,000, so I can start doing basic arithmetic operations, additions, subtractions, divisions, modular operations. We can certainly do that in here. Now the next thing that we want to see, in addition to the basic arithmetic operations that we can do, is what about Java functions? What about the entire library of Java functions that are available out there? We can certainly take advantage of those as well. So in addition to doing just your basic arithmetic operations, we can also take advantage of Java functions. If you're familiar with Java, anyone who is familiar with Java, let me bring this on the screen here. Java is powerful because it provides a library, a huge library of functions that anyone can take advantage of. And I just Google here on the screen. Java just does provide a huge library of functions that anyone can take advantage of. So if you're familiar with Java and you know some of those functions, the beauty of Talend is we can incorporate any of these functions into a job. The example that I'm going to give here is, let's say we wanted to cast this as an integer, as an example, assuming that this is a float actually. So assuming we wanted to cast that as an integer in Java, we can just simply take advantage of a natural Java function as integer dot pass int, and we can wrap that around this particular job, and that will be legitimate. Of course, we're gonna have to change the data type here, but we can do things like this, right? Casting to integer, casting to strings, and all of that. We can then totally legitimately do something like that within the tMap. And this just unleashes an enormous amount of potential for transforming your data when you now have the whole library of Java at your fingertips to transform that data. I think that's really powerful. That said, I'm gonna revert this and keep it as such, so we have a float coming in there. The next thing I wanted to show was defining constants. So in addition to just defining transforming the data that we have, we can define constants and use that constant within our output table. So you can imagine you're loading a data warehouse, you might need to derive surrogate keys or such, all right, or natural keys for your records, or just your run date and all that kind of information. We can certainly go ahead and be able to derive that, because those are constants within the ETL process. So here I'm going to go ahead and add a new expression or new variable in the middle. So this is where we define those constants, all right, and this is where we'll define a new constant for the job. And this constant I want to define here would be the ID. So imagine loading a data warehouse and we need to generate a sequence ID for it. So this is where I'm going to define that constant, and let's call this ID. So we're going to call this constant ID, but instead of just writing 1 and 2 in here, is going to be impossible to do. So I need a function for me to do that. I can go ahead and click on the little ellipse in here, and this shows me even more functions that are available within the Talend environment. So this is called the expression builder. If I go into that expression builder, I can see Talend specific functions. All right, let me expand this to be a little bit bigger. You can see the library of functions that are available for us to use, whether we're talking with dates. One of my favorite is to get date, get current date when loading to a data warehouse. So I can load that current date into the data warehouse as a load date. We can see string functions, we can see mathematical functions. So any mathematical operation we might want to perform, we have a function for that. Data quality, especially important. Data operation masking, so AES, DES, masking and obfuscation, and you can definitely use your encryption key as well in this case. Just a library of function, which is very powerful. Plus you can define your own user defined functions as well, and certainly use that in here. That's a little bit above the scope of this particular video. I think there'll be a separate video for user defined functions, but in case you had a user defined function specific to your organization you wanted to call, say there's a particular way you can generate customer number, or there's a particular algorithm you use to validate user information, you can encapsulate that into a function, and we can certainly make that function available in here. Now that said, the function that we need for today is going to be a numeric function. So this is the function that we need to generate sequence. So I'm going to go ahead and bring the numeric function. You can click and bring it to the screen. So the numeric function gives us the ability to generate sequence, right? So you can pick your start value and you can pick how much to increment. So I'm going to start from 1, and then I'm going to increment every the digit by 1 every single time. All right, so very straightforward, very simple. I now have my numeric function, and this is going to a variable, and now I can take that variable and bring that into my output. Just like the way we brought in the input here to the output, I can now bring that variable as well into my output, and this variable now is a constant, or in this case it's just generated based on this particular function to give me my key. All right, so basically my surrogate key I can use in loading my data warehouse. That said, let's go ahead and test this. Let's go ahead and test this particular just to see that we're generating the keys. It should just give us 1 to 10, very basic, nothing complex. right, doesn't seem to like something about what we're doing. All right, so let's see why that is. I think here we're generating an integer. We need to, since it's a numeric, of course, we want to make that into an integer and make sure that the data type here is an integer as well. Very important that the data types are consistent. All right, so this should now give us the output data set with the sequence attached to that, and that sequence is coming from a function that we've defined. All right, and so you can imagine really augmenting your data set with, you know, the library of functions, whether it's custom functions or the functions that are available out of the box. It really gives you tremendous potential to massage and clean up the data set. Now, the next thing we're going to see is just maybe adding some more conditions in here to see more transformations around this data. What I want to do is add a new column to my output. All right, and this column should just tell me if my customer ID is even or odd, just to show us some basic ideas around doing, you know, more transformations within Talend. So we're gonna do that basic transformation to see if my customer is even or odd. So now I've defined this. Actually, odd should be with 2 D's, not 1. So I've added a new output column, but I can go ahead and fill in the value here, right? So I can make this into a constant and say, you know, odd, right? That's not actually correct. It just doesn't really make any sense, but let's just get an idea of what we're trying to do here. All right, so if I run this job, it's just gonna put odd in there, right? But I want to replace that with the logic that can determine, all right, is my customer even? Then we say even. If it's odd, then we can go ahead and say odd. All right, so here it just says odd, 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 but we need to look at the customer number and then determine, or we maybe need to look at the sequence and then determine that is that even or odd. So that's really what we want to do, because sometimes you're not just, you know, you might want to create a column, a derived column based on some other column. So this really gives us the ability to do that. So let's go back into that tMap component. Of course, we're going to replace that. And what column are we looking at? Let's look at the variable ID. So let's look at this column. I can just simply bring that here. And what's the basic way to determine if something is even or odd, right? So that would just be doing a modular operation on that. So mod 2. All right, if I just do this as such, what this would do is it will simply just print on the screen, you know, 1 or 0. Actually, it's gonna print, yeah, 1 or 0, and that would tell me even or odd depending on what that modular operation is. And then after that, I can then throw in my conditionals to say, is this even or odd? So let's just go ahead and run this, and then I'm gonna make this even more interesting. Okay, so it doesn't like that data type, so we always have to be careful with the data type. So this is giving me an integer, so we want to make sure that we're changing this result into an integer as for the output. So that's why that complains. Then I'm gonna go ahead and rerun the job one more time. All right, so you can see I have 1 and 0, 1 0. All right, so when that's odd, it says 1, 2 is even, it says 0, 3 is odd, 4 is even. So we're getting it correct. But I don't want to just say 1 and 0. I actually want to print even or odd. So I need to put in more logic in there to go ahead and actually print that is this even, or is this an even number based on that logic, or is it an odd number? And the way we would do that is I'm going to go back into the tMap. I can do the edit here, but I prefer to have the canvas open. So click on the ellipse so I have more real estate, more space to work with. So again, Talend does provide the entire, you know, capabilities for conditionals, and this is talking now about if we go back to the agenda, we're talking about conditionals here, if and else statements. So we can certainly put if and else conditions within the Talend job. So what does that look like? What does that look like when we do the if and else statements? Now we know we're looking at this value, variable 1. All right, so what happens if we do this modular operation and the result for that equals, all right, so just very basic syntax, like almost like you write in Java, but this is just a conditional scripting within Talend. So what happens if that equals 0? Okay, so what do we want to do? We want to say if it equals 0, return true. All right, but what if it's not 0? What if it's not 0? So I put a semicolon there. What if it's not 0? Okay, I want to return for actually not true. We're not talking true here. I want to say even. We're saying odd. All right, I'm returning a string that says odd. Okay guys, so very basic syntax, very basic syntax. If you wanted to make this even more interesting to see how we can use those functions, let's put this as even and say to, you know, upper case, and I can call it to uppercase. All right, we can say odd and then say to, and as long as you start dot, you know, in Java dot, and then you have the whole library of functions. To, as you can see me typing, it shows that to lower, and I can take that all to lower. All right, and we can even go ahead and nest this condition. So here is an if else. So if this is true, that's the result. If it's false, so else, put that in here, and you can just repeat that and nest it as much as you want. Usually we don't want to make things too complex, but if you really had to do that, then you can go ahead and nest that. All right, so this gives us a very basic conditional that we can use within our job. All right, so let me do okay on that. All right, so we have everything in there, but now we notice I'm returning a string. So no longer am I returning an integer like we did before. So I have to make sure that my data type here is reflecting the fact that I'm returning a string, you know, in quotes. So let's go ahead and do okay. Run this. Hopefully it runs without any errors. If there are errors, we're gonna have to resolve those. All right, so this worked like a charm. So we can see here even, or actually odd, it tells us that's odd. Even is even, and it's actually going to the uppercase and the lowercase. Right, so very basic scenario here, not very useful if you're trying to build a data warehouse, but you can really imagine doing something like this where you're checking maybe the customer account, is their balance too low or is their credit risk too high, and then, you know, creating more derived columns as part of that, or we can be masking that information. I believe my data set did have, if I wasn't right, if I did get it correctly, and this is just all a dummy data set, I believe it did have date of birth, and let's see this data set which I made up. Social Security, assuming that this was Social Security. Of course, Social Security doesn't look like that, but assuming that this was Social Security, we don't want to load this into data warehouse, all right? Especially with GDPR and CCPA and all of that. All right, we'll have to make sure that we mask this, and so we can take advantage of all those functions to really transform this data. One other thing that I'm seeing here is say customer name. We might want to split out the customer information, right? Or maybe add some prefix to that customer information. Now we can do all of that. All right, if I decide to say, all right, we want to call this, instead of just putting the customer name, let's prefix Talend to all the customer names with a space. We can certainly do that, and so you have a lot of power to really transform and to work with the data. So let's see what this comes back with. We should expect to see Talend in front of all the customer names that we have out there. All right, so that's what we have. All right, really good. Now we're gonna continue a little bit on the conditionals here to talk a little bit more. So we've seen calling arithmetic operation. We can do string operations, which we saw. We can invoke all the libraries that are available within Java, a lot of the libraries that are available within Java. We can call the Talend built-in libraries, which we saw. We can define we can use your own custom libraries or functions by calling them in the routines. we can do conditionals, but I want to talk about the conditionals even more. And the reason for this is we're doing a join, and what typically happens when we do a join, all right, we might have rejects. We might have what happened to the 10 or to the 3 records in here that did not meet my criteria. What happens to those records, right? Do they just disappear? What do I do with them? So especially when loading a data warehouse, it's very important to think about what happens to those edge cases, to those rejected records, to those records that don't meet matches. Or we might just want to split out the record sets to different tables. All right, so what if the requirement was all the even records go to one table, all the odd records go to another table, right? So separating that, how do we accomplish that within the tMap? And I'm gonna go ahead and show that here in a second. The way we do that is we can add a new output within the tMap, and let's call this rejects non-matches actually, and we can add as many outputs as we want, and then let's call this rejects. All right, you can really add as many. I don't think there's any limit to the number of outputs that we can certainly add here, so you can add as many outputs as you want. All right, so in this case I'm gonna have 2, one which is the non-matches, the third which is the rejects. All right, so what do I want in the non-matches? What I need to do for this now is separate my record sets. I want to separate my record sets. So up here I want just those even numbers to go up here. So in here we can certainly do a lot of configurations here. All right, one of them, if you click on the little engine there, is to catch output rejects and to catch inner join rejects, and I'm going to talk about that in a little bit. So let's close that. The next one is to filter. All right, so we can put in expressions here that would filter the record sets that make it to this output, and this is what we really want to use. All right, so remember here we want, say in this case, if we want just the say even numbers to make it here, we can then write that logic or that expressions here to ensure that only even numbers make it here. So the way I would do that is I can bring in my value, because we know this is my sequence, and I'm going to check that sequence and say, is that mod 2 equals 0? If that's the case, then it filters, because this is just a filter. All right, so if this value, if the expressions evaluates to 2, that record, it evaluates to 0, that record makes it here, and we expect only the even records should make it here as such. All right, we expect only these even records to make it here as such. So very powerful. Now if we wanted to do the odd records, what do we do? Before I copy that, I'm just gonna do I can select all of that and copy to my output. All right, so I have the same records in the output, and then we can do the same here. You can just copy to this output. So my 3 outputs are as such, and not every column needs to be in all the outputs. So depending on what you need, you might send different columns to different outputs, but in this case I'm keeping them the same. Here, if I filtering for just when this expression evaluates to 2, which is even number, I send that record here. Now if I want to filter for this one, I'm gonna say if that record evaluates to 1, what is that? That's an odd number, right? That's odd. Then I'm gonna send the record here, so only my odd records will make it here. All right, now if I run this, let's actually go ahead and run this for a second, and then I'm gonna come back and make some comments a little bit about what exactly we're doing here. So let's we have our customers there. If we run this now, let's just run this for a second here to see what do we expect to go up there. All right, we expect just the ones that evaluate to even. If I got my logic right, it should be just the ones that I've evaluated to even that would make it to this output. All right, and so that's what we're getting here. So just the even records are making it here, and you can clearly see that. But what happened to the odd records? I can just do a tlog row now. All right, and this could be an output tape, this could be a database, it could be a file, but we're just writing it to the screen. So let me go ahead. You see now I have a new output coming out from here that says non-matches. So this is what I want. So I'm going to put the non-matches here. Let me disable this for a second so we can see what's coming in the non-matches. All right. So deactivate that, and then we can look at the non-matches. So the non-matches should give me the odd records. So I should get the odd records coming in the non-matches. Let's just validate that that's the case. All right, so there we have it. So the odd records are coming into the non-matches. But what we want to pay attention to in this case is, if you notice, and I don't know if this shows very well on the screen, that I'm getting this record here. This record is a null value and it's not finding any match. Like, why am I getting this record here? Clearly, it seems like it's a bad record. All right, and this is the case of if you're loading, typically if you're loading a data warehouse or dimensions and such, you might be familiar with things like late arriving dimensions and all of those things where you have your transaction coming from your fact table, but you're doing a lookup against your dimension. Customer hasn't yet been entered in there, and you're getting null values because the join, we're doing a left outer join, and this is a problem. Wow, but if we did an inner join, we might just miss records. So we don't want to do an inner join. This left outer join is giving us null values that might go into a table. How do we cache this reject so we can send it somewhere else for processing? And that's what I want to capture in the third column. So just bear with me here. Let me expand this down. So I'm gonna disable this output, and I'm gonna do another tlog row here. All right, and this tlog row would be for my reject. All right, so let's handle this third scenario. So in the first scenario here, we saw that we can get just the odd numbers. In here, we can get the even numbers. But what about these third scenarios to handle the rejects? All right, so basically what we want to do is cache things that don't make it here, and things that don't make it here, and then things that are rejected for one reason or another. All right, so let's go ahead and run this flow. There's going to be an error, there's going to be some issues, and I'm going to go in step by step to show how we can resolve those issues. Usually when we do joins and lookups and things like that, all right, it gets tricky really quickly. We can go in to see exactly how we can resolve those the issues that we might encounter. All right, so this just run and completed, and I didn't make a change. Let me actually go in and undo that change, which is my inner join here. Let's keep that into a left outer join. That was one thing I did change really quick. If I run that, what we'll notice is two issues off the bat. All right, the first issue is I don't expect to get every record here because those records should have been filtered up here. So how do I prevent those records from making it to this output, which is really what we want? And the second issue would be, and we just saw it here, was my join is a left outer join, and so it's going to be sending me records in here that could potentially be problematic, and I'm going to see how to filter that. So right now, what is coming into my rejects is first is giving me all these records which I don't want. And the reason why it's giving me is because of that left outer join, and we're gonna fix that. And then second, I'm seeing these null values, and what this is telling me is something is not being caught up in my join, especially with that left outer join, and that's why we're seeing these null values. And if you think about the data warehouse scenario, we can either just choose to ignore these values, or this might just be late arriving dimensions, and we need to deal with them accordingly. So we can just make them disappear out of the ETL process. All right, so how do we resolve this to ensure that this don't show up in our rejects criteria? Because of course those have been taken care of above. And secondly, we only see the records that doesn't meet the join criteria. All right, so those are the two things that we need to fix. So the first fix that we can do is what I just did a little bit earlier here, is we can go into that join criteria, change that to an inner join. All right, change it to an inner join. But I'm sure everyone there is looking at this and screaming and saying that's wrong, that's not correct, that will give you an issue, and you are right. Okay, because if I change that to an inner join, it's just gonna give us what we saw before. Okay, it's not going to give me my null values, but that's really what I want. I want the null and rejected values coming out here, but the inner join will not give it to me. So let's see that issue, and I will show us how to fix it. So let's this run for a second. Okay, so now it didn't fix the issue. As a matter of fact, it's caused more issues. All right, one, I don't see those null values, and two, I still see these records coming here. So I can filter those records here very quickly. There's an easy way to filter that. If we could filter records here, we can easily filter records in the rejects as well. All right, so I can just go ahead and filter that record. The way I would filter it is, because I know my join key here is customer number, I can take the customer number and just check for if it's null. All right, just filter records where the customer number equals null, and that should solve the problem very quickly. All right, so let's try this one more time. So now I'm filtering those records. I'm filtering for records where customer number equals null, but it's still not exactly what I want. All right, because what we'll notice here is this will give us no records. This should give us no records, but I need records. I need those two records. All right, so now this has given us no records. That's still a problem. So let's go in with the last fix that we're going to do here, which is very simple to do. Is we want to come in, and if you click on this little tMap setting, it unleashes, or it opens up this configuration, and this is what we need. All right, so here we can catch output rejects. We want to set that to true, but more importantly, and this is what I've been building up to all along, we want to catch the inner join rejects, because we're doing inner join here. If there are rejects that are coming from this inner join, those values, those null values that we see, we want to cache them in here, and so that should give us those records. All right, so those inner join rejects should be showing up here now. So we should see those two, I believe it was two records that were a little bit problematic. Those are the records that should show up here. All right, guys, so there you have it. Now I have those two records. These are truly my rejects that I want. I'm not getting all the other records because I filtered them out, the records that were making it up here. All right, those records should have been taken care of up here. And then secondly, I'm getting just the ones that have been rejected, that did not have a match key, and those are the records that I'm making it here. I can go ahead and let's make a change to my orders and throw in an order number of say, let's just add a new order number here. All right, and then call it, say, 15. Right, I don't think we have 15, so let's throw this order number of 15. All right, so now I should expect to see that making it here, because I've introduced a new order number of 15, but I don't have a corresponding in my customer table. While that's running in my customer table, there's no corresponding order of a number of 15. It's kind of hard to look at this way. Let me zoom in. There is no corresponding 15 in here, so I don't expect to see that. All right, so if the job runs, what I'll expect to see is that record should show up in my rejects very quickly. We can call these rejects, we can call it a table that needs to be reprocessed, and so there we have it. All right, we can call it a table that needs to be reprocessed. I think I've gotten one additional record in here, and this is actually you can ignore this. This is actually the surrogate key. This 13 is not the key. This is just the sequence that we generated. So that's why you see it, showing up there, not necessarily 15. But yeah, but the actual number, if you want to really verify, is 865 15 plus 5,000, because we were adding 5,000. So I know for sure that's the record. Okay. All right, guys. So there you have it. I know this was a little bit, I hope not complex, but this captures a lot of the scenarios that, when doing processing, data loading, we might encounter. All right. It's not just as usually as simple as, all right, let's just take a table and load it or a file and load it into a table one-to-one, right? How do we manage all those edge cases? How do we deal with missing records, late arriving dimensions? How do we deal with routing records to different tables based on certain conditions, based on certain criterias? All right, and we can stack them up. I can do the processing within this tMap and stack it up to another tMap, and so now you really have that power to orchestrate or to sequence a lot of very robust processing within the pipeline. Before I go, one of the things that I just have to show this, just because I don't think it would be really nice to leave without showing it, is we can, if you have social security, which I just call that field social security, it's not real social security number, but we definitely want to take advantage of some of these encryption or masking kind of capabilities to make sure that we're not loading sensitive data into the data warehouse. All right, so just something to be aware of, right? Maybe AES security in here, we can mask that with, and I'm gonna go ahead and show that. I can just go ahead and mask that, so automatically masking this SSN, and then you can just place in your key here. This is just ideally this should be your company key, which you can load at runtime to make sure that it's very secure. So I just have to really show that, just because again, once you're talking about building a data warehouse, security really becomes important. Let's run this job. All right, and while that job runs, I'm gonna get ready to bring up the PowerPoint. All right, so there you have it. And now my social security is kind of masked, right? This might be or might not be what you need, but at least it gives you an example of being able to take disparate data sources, do some aggregations, do some mapping, transformations, validations, and being able to write that out into different destinations. And this could be going to Snowflake. All right, this could be, that destination could be a Snowflake destination. All right, it could be a BigQuery, it could be a Redshift, it could be whatever destination, we fly a file somewhere, a Hive table. It could really be any destination that we want, right? Or just Oracle or Netezza or DB2. That could be any destination that the company might be working with. All right, guys, there you have it. Just to recap what we've seen in today's presentation, which has been a deep dive of the tMap capability within Talend. What we saw was being able to perform basic mapping capabilities. We've seen arithmetic operations, being able to call the Java class methods. So methods that are available within Java, like integer.parseInt, integer.parse string to string, and uppercases, and all the transformations that are available within Java, we can call those. And then the ones that are available within Talend, both system routines and customer or custom defined routines, we can call that. And then last but not least, we've seen conditionals, if else statements, both at the level of a specific output and also at the level of sequencing that into multiple outputs, so we can write to multiple different destinations and handle a lot of scenarios with ETL or loading of potentially a data warehouse. All right, guys, thanks for watching. This is Fru. I hope this was helpful. If you have any questions, don't hesitate to go into the comment section below. Let me know. I'll be more than happy to respond. If anything did not make sense, if there's any resource that you might need, I'll be more than happy to get your comments, to get your feedbacks or the challenges that you might face, and be able to respond to that. All right, thanks for watching. I will see you in the next video.